इयत्ता 9वी आणि 10वीच्या मित्रांनो, आज आपण त्रिकोणमिती ट्रिग्नोमेट्री या नवीन टॉपिकचा विचार करणार. या टॉपिक मध्ये समान गुणोत्तराबद्दलची एक गोष्ट आपल्याला माहिती पाहिजे. When ratios are equal, let us revise that property. We know that if A upon B is equal to C upon D. Try to remember this property. If A upon B is equal to C upon D, then we can write A upon C is equal to B upon D. A upon C is equal to B upon D. This is, you know, that alternative. Ekantar kriya. Or even though you can see that C upon A is equal to D upon B. You know that this is alternative ekantar kriya. But to understand this property, if you know that 4 upon 3 is equal to 8 upon 6, two ratios are equal, then definitely you can write that 4 upon 8 is equal to 3 upon 6, or you can see that 8 upon 4 is equal to 6 upon 3. So this is by alternative, ekantar kriya. तुम्ही या समान गुणोत्तरांचा विचार करा, तुम्हाला एक खूपच सोपी गोष्ट कळणार आहे. When two ratios are equal, suppose three ratios are equal there. What is that? O1 upon O2 is equal to A1 upon A2 is equal to H1 upon H2. Three ratios are equal, and O2 upon O3 is equal to A2 upon A3 is equal to H2 upon H3. Three equal ratios are there. Three different equal ratios are there. Now, if you write here first and last ratio equal, you can see that by taking two ratios equal, O1 upon O2 is equal to H1 upon H2. Two ratios are equal. And if you take alternative, by alternative, what is that? You are getting O1 upon H1 is equal to O2 upon H. And if you consider the first ratio with the third ratio, they are equal. What is that? O2 upon O3 is equal to H2 upon H. And if you do that alternative, what are you getting there? O2 upon O3 is O2 upon H2, alternative O3 upon H3. Now, if you can see that three ratios are equal there. By taking any two ratios, you can select. And if you do that alternative like this, very, very interesting property you are finding. What is the property you are finding there? O1 upon H1 is equal to O2 upon H2. That is equal to O2 upon H2. O2 upon H2 same. And it is equal to O3 upon H4. So what is that you are getting here? Very, very important result you are getting. O1 upon H1 is equal to O2 upon H2 is equal to O3 upon H3, like that. So when three ratios are equal there, and three different ratios are equal there, and if O2, A2, H2, O2, A2, H2, common numbers are there, and if the common numbers are there, we are getting this result. What is that result you are getting? O1 upon H1 is equal to O2 upon H2 is equal to O3 upon H3. So this is by using two equal ratios and by using alternative. दोन समान गुणोत्तर आणि त्या दोन समान गुणोत्तराचा विचार करून जर आपण एकांतर क्रिया केली तर असे मजेशीर गुणधर्म आपल्याला बघायला मिळतात. आता हा गुणधर्म, ही प्रॉपर्टी आपण दोन काटकोन त्रिकोण आहेत, दोनापेक्षा जास्त काटकोन त्रिकोण आहेत. Two right angle triangles are there, many right angle triangles are there. and if they are similar, जर ते समरूप असतील तर काय प्रॉपर्टी मजेशीर बघायला मिळते त्याचा आपण आज विचार करूया. टू राईट अँगल ट्रायंगल्स आर देयर. व्हॉट इज दॅट? A, B, C. Right angle triangle is there. Another right angle triangle, A, D, E. When you observe carefully, A, B, C, right angle triangle, A, D, E, right angle triangle, you can say that angle A is common between two right angle triangles. B is 90, D is 90. So, definitely remaining third angle C and E are definitely congruent. So, at least we know that when in two triangles, दोन त्रिकोणामध्ये जर संगत कोन एकरूप असतील, corresponding angles are congruent, then the triangles are similar. They are called similar. So, definitely what is interesting here, you are getting triangle ABC. A, B, C. It is similar with triangle A, D, E. A, D, E. You are finding that triangle ABC, ABC and triangle ADE are similar. By AA test, you can use that, one of the tests. But you know that by the definition of similarity, corresponding sides are in proportion. Corresponding sides are in proportion. So, what is that? Corresponding sides are in proportion. You can see that AB upon AD, AB upon AD is equal to BC upon DE is equal to AC upon A. Corresponding sides are in proportion. That is the definition of similarity. समरूप त्रिकोण असतील तर संगत बाजू प्रमाणात असल्या पाहिजे. आता संगत बाजू प्रमाणात असल्या पाहिजे हा विचार जर इथे केला आपण, संगत बाजू प्रमाणात असल्या पाहिजे तर आपण काय लिहिता येईल? We can write like this: AB upon AD is equal to BC upon DE is equal to AC upon AE. This is the reason corresponding sides are in proportion. And if we write like this, corresponding sides are in proportion. And now let us see that with the help of angle A, this is acute angle. In the right angle triangle ABC, it is acute angle. What is the side AB? Let us call that side. It is adjacent to angle A. Side BC, it is opposite to angle A, and AC is hypotenuse, like that. So we can try to use that adjacent, opposite, and hypotenuse. So what is that? AB, you can write that AB, it is opposite side. Opposite in the first line. We have written that corresponding sides are in proportion. After that, consider angle A. And with respect to angle A, AB is adjacent side. And BC is opposite side. BC is opposite side. And AC is hypotenuse. So, let us use that AB, that is adjacent side of triangle 1, AB. And what about this BC? It is opposite side of triangle number 1. And AC, we can take it is the hypotenuse of triangle number 1. Similarly, let us take the ratio there. What about AD there? AD is the adjacent side of angle A. So it is the triangle number 2. And DE is opposite side of triangle in the triangle number 2. it is opposite to angle A, and this is AC, that is the hypotenuse of that triangle. So all ratios are equal. All ratios are equal. We are using purposely, this is adjacent, this is opposite, and this is hypotenuse. AD is adjacent side to angle A. DE is opposite to angle A, and AE is the hypotenuse in the second triangle. Now, if you draw another triangle there, like this, now consider triangle AFG. It is again right angle triangle, and you compare with the triangle ADE. You can see that triangle ADE is similar with triangle AFG. AFG. Two triangles are similar by again AA test or AAA test. You can write the corresponding sides are in proportion. What are the corresponding sides? AD upon AF is equal to DE upon FG is equal to AE upon AG. So this is your first triangle, this is your second triangle, this is your second triangle, and this is your third triangle. All triangles are similar with each other. 1, 2, 3. Three triangles are similar. They are right angle triangles. And in the third triangle also, if you consider angle A, acute angle, AF is adjacent side, then FG is opposite side, and AG is hypotenuse. So you can see that AD is adjacent side in the second triangle and divided by DE. What is that DE there? DE is definitely opposite side. So AF, what about AF? It is adjacent side. So this is adjacent side of triangle number 2, and this is adjacent side of triangle number 3. It is equal to DE. DE, you can see that. What is that DE? DE is opposite side in this triangle number 2, and FC is opposite side in the triangle number 3. AE, what is that AE there? It is hypotenuse in the second triangle. It is hypotenuse in the second triangle. What about AG there? It is hypotenuse in the third triangle. So we can use, this is our O2 upon O3 like that, and the third ratio H2 upon H3. Now, if you consider two equal ratios are there. What are two ratios equal there? O1 upon O2 is equal to H1 upon H2. And what are two ratios equal? Two equal ratios. After taking two equal ratios, we can use alternando like this. Let us use alternando and then find out what is that interesting result you are getting. If you consider this pair, and by taking alternando there, what is that alternando? O1 upon H1. You are getting result. What is that result there? O1 upon H1 is equal to O2 upon H2. O2 upon H2. And here, if you use that alternando, एकांतर क्रिया जर वापरली, तर काय रिझल्ट येतो तुम्ही? by alternando O2 upon H2 is equal to O3 upon H3 by alternando. And when we use that alternando, very important result you are finding. You can see that O2 upon H2, O2 upon H2, it is equal, same ratio. So what is the last result you are getting there? That is very important for you. You are getting O1, here O2, the third ratio O3, they are equal. Denominator is H1, denominator is H2, denominator is H3, all are equal. You are getting, what is the result? O1 upon H1 is equal to O2 upon H2 is equal to O3 upon H3. You can see that in the diagram. This is your opposite side with respect to angle A. This is your opposite side with respect to angle A. This is your opposite side with respect to angle A. And you are getting that, what are you finding there? O1 upon H1 and is equal to O2 upon, you are getting H2 here, like this, O2 upon H2. And what is the third ratio you are getting there? You are getting O3 upon, this is, you are getting H3. And if you draw again right angle triangle, if you take any point on this ring and if you draw perpendicular there, you are getting another right angle triangle. You can see that there are infinite number of triangles which are similar with each other, but you are getting that O1 upon H1, O1 upon H1 is equal to O2 upon H2 is equal to O3 upon H3. And if you are getting that result, what is that result? You are finding the ratio of opposite side and hypotenuse. Opposite side and hypotenuse. Opposite side and hypotenuse. It is constant. And that, let us name the ratio, it is as sine. So this is the first ratio. We are finding that the name of that ratio is sine. The name of the ratio is sine. So this is sine. And you can see that if you take the ratio A1 upon H1 is equal to A2 upon H2, you are getting A2 upon H2 is equal to A3 upon H3. So what is that? Another ratio you are getting. This is adjacent side, A1 upon H1. This is adjacent side, A2 upon H2. This is adjacent side of angle A, A3 upon H3, like that. And if you name that ratio adjacent upon hypotenuse, that will be cosine. And even though you are getting the ratio O1 upon A1 is equal to O2 upon A2 is equal to O2 upon A2 is equal to O3 upon A3, and let us name that ratio tan. So very, very important ratios we are finding. What are the ratios there? You can see that you can prepare a table like this, and what is that you are finding there? This is opposite side and this is hypotenuse. This is adjacent side and this is hypotenuse. And the next third ratio you are getting like this, opposite and adjacent. So what is the first ratio? Opposite upon hypotenuse, let us call it as sine. And if you take the ratio adjacent upon hypotenuse, let us call that it is cos. And if you take the ratio opposite side upon adjacent side, let us call that ratio tan. So these are basic three ratios. When two right angle triangles are similar, and if you consider the angle A, which is common between them or which is congruent between two triangles, you can see the ratio of opposite and hypotenuse. It is remaining the same, and that is called sine ratio. Adjacent upon hypotenuse, this ratio is called cos ratio, and opposite and adjacent, we are calling it tangent ratio. And if you take the ratio reciprocal adjacent upon opposite, let us call that ratio as tan. And if you Take the reciprocal h upon a. Take the ratio h upon a. You can call that ratio like sec. And if you use this ratio, you can call this ratio h upon o, that is cosec. So in all, first basically three ratios are there. Sine. पहिल्यांदा तीन गुणोत्तर पहिल्यांदा समजले पाहिजे. अपोजिट अपॉन हायपोटेन्यूज, समोरची बाजू भागिले कर्ण. ऍडजसंट, लगतची बाजू छेद कर्ण, त्याला म्हणायचं कॉस. आणि समोरची बाजू आणि लगतची बाजू त्याला म्हणायचं टॅन. आणि त्याचे जे रेसिप्रोकल आहेत ते मराठीमध्ये त्याला पाहिजे त्यांनी हा टेबल लक्षात ठेवायला हरकत नाही. हा टेबल कसा बनवता येणे शक्य आहे बघा. मराठीमध्ये हा टेबल असा बनवू शकता तुम्ही. हा बनवू शकता तुम्ही मराठीमध्ये, हा रेशो बनवू शकता. आणि याच्यामध्ये जी नाव काय येणार बघा, तुम्ही नाव लिहिणार साइन, याचं नाव लिहिणार कॉस आणि याचं नाव लिहिणार टॅन. हा रेशो उलटा घेतला, ल छेद स घेतला की इट इज कॉट. आणि हा क छेद ल घेतलं तर त्याला म्हणायचं सेक आणि याला म्हणायचं कोसेक. याचा जास्त प्रयत्न केला तर तुम्हाला बरं पडणार. तर हे बेसिक थ्री रेशोज आर देयर. आणि आफ्टर दॅट थ्री रेशो, in all 6 ratio, very interesting आणि important आहे. sin cos tan डेफिनेशन लक्षात ठेवायची. आणि cot त्याचा इन्व्हर्स झाला, त्याचा गुणाकार व्यस्त घेतला की h upon a घेतला की sec म्हणायचा आणि h upon o घेतले की cosec म्हणायचा. आपण हा पहिला पार्ट इथपर्यंत घेऊन आपण नेक्स्ट लेक्चर मध्ये आपण पुढे कंटिन्यू करूया. हा त्रिकोणमिती ट्रिग्नोमेट्रीचा पोर्शन दोन्ही स्टँडर्डना 9वीच्या आणि 10वीच्या उपयोगी पडणार आहे, याच्याकडे आपण लक्ष द्यायचं आहे.